Let's talk a little bit about the three trigonometric ratios. But first we need to understand about labeling sides of a triangle. So in the top triangle here, we have this Greek theta, which indicates a reference angle, and that's the angle that we're referring to when we name our sides. Because unlike in the Pythagorean theorem, the names that we call the sides of a triangle when we are using trigonometry depend on the reference angle. The first side, which we know from using the Pythagorean theorem, is called the hypotenuse, the longest side of the triangle. And that's always the hypotenuse regardless of which angle is our reference angle. Here we can see on the second triangle as well, it is the hypotenuse. The side directly across from the angle is called our opposite side because it's opposite the hypotenuse, opposite the reference angle on our triangle. And the third side is called the adjacent side. That is adjacent or next to the angle. And you see when we look at our second triangle here, that the opposite side is still on the opposite side of the triangle, right across from the reference angle. You can see that that's a different side than when our reference angle was in the other corner. However, because it's opposite the angle, it is still the opposite side, meaning that third side is our adjacent side. It's important to be able to name and communicate about our angles and the sides of our triangles. When we're talking about trigonometry, we always involve angles, whereas with Pythagoras, we only deal with sides. In trigonometry, we deal with angles as well. And there are specific ratios between the lengths of sides on a triangle, no matter how large or small that triangle is. If we take a triangle with a given reference angle, say 30 degrees, no matter how big or small we make that triangle, it will have the same ratio between its side lengths. The first ratio that we talk about is called the sine ratio. On our calculators, we abbreviate sine to sin. The sine of that angle is a ratio between the length of the opposite side and the length of the hypotenuse. No matter how big or small I expand this, if I keep the ratio the same, if I make it just bigger or smaller without changing the angles, its opposite over its hypotenuse will always be the same. Its sine ratio will always be the same. Our second ratio is the cosine ratio. And the cosine ratio is abbreviated to cos. Cosine of the theta. Cosine is the name of the ratio between the length of the adjacent side and the length of the hypotenuse. In our triangle, it's the length of the adjacent side and the hypotenuse that I've highlighted there in purple. Our third ratio is the tangent ratio, which is abbreviated to tan theta. And so the tangent ratio is a ratio between the length of the opposite side over the length of the adjacent side, which I'll colour in so that we can see on our triangle, opposite side over the adjacent side. And that is our tangent ratio. Now, which ratio we choose depends on which sides we are dealing with. We'll normally have information about one or maybe two sides of the triangle, and that can help us to determine which of the three ratios we want to use. There's a silly acronym that we can use to help us figure out the ratios, and that is SOH CAH TOA. SOH-CAH-TOA. It's not a real word, but if we have the opposite and hypotenuse sides, we use sine. If we have the adjacent and hypotenuse, we use cosine. And we use tangent when we have opposite and adjacent. So if you can remember that word SOH CAH TOA, it's going to help you to identify whether to use the sine, cosine, or tangent ratios. If we have a triangle such as this one, where theta is our reference angle, if we knew the sides were x, y, and z, we could write the sine, cosine, and tangent ratios for this triangle. Or perhaps instead of x, y, and z, we'll use a number. That might make it a little bit clearer. So 5, 4, and 3. So if we wanted to write the sine ratio, we would write the opposite side, which is 4, over the hypotenuse side, which is 5. That's the ratio of the side lengths. We could write the cosine ratio as the adjacent side, which is 3, over the hypotenuse side, which is 5. And we could write the tangent ratio as the opposite side, 4, over the adjacent side, which is 3. And we've got a ratio that compares each different pair of sides there. And so to determine which ratio to use, it depends on which sides we are referring to.